All right, so on a more detailed lesson learned, when we have a graduated cylinder, again, oops, I hate when let me just. So when you have a graduated cylinder, there are graduations. There are these little marks on a graduated cylinder. This is a graduated cylinder. This is what we use. It's a cylinder. Obviously, graduated means there's marks that you can read. With a beaker, often they do have marks. Beakers do. This is what a beaker looks like. I showed you an example of it earlier today. So this is a beaker. They also have marks, but these are just estimates. These are not accurate. What you used over here were bottles. You had bottles that had specific volume or specific concentrations here. These are just bottles. So a couple of vocabulary words that can be very important. So this again is a beaker. Beakers we use to hold the liquid, to mix them, to run a reaction. A graduated cylinder is used to measure volumes. All right, let's talk about the word concentration. So what are you going to be tested on Monday? So on Monday you will have a quiz. And your quiz will be on, obviously, what is a control, which of these is a control group, which is an experimental group. So you should be able to identify, right, which of those they are. So that's key. You've read the chapter, theoretically. You've read the chapter, you've taken notes, you've done the lab, you've set up the lab, your procedures, you designed your experiment. So you should understand that by now. If you don't, see me tomorrow morning. Is everybody in the room? Did the people in the hallway come in? Okay. So concentration is, before we can talk about concentration, I have to discuss 3 vocabulary words, and that's solute, solvent, and solution. So those are 3 very important words. Solute is what is dissolved. A solvent is the compound doing the dissolving. So, and the solution is the result. That's what you get when you mix the solvent and the solute. So a really great example is salt. Would be the solute. Water would be the solvent. And the result is salt water. When you look at, how do you know it's a, by the way, when we're talking about a solution, it's a homogeneous mixture. It's just a mixture. When we talk about dissolving, the word dissolving, it's just one is being surrounded by the other. It's not a chemical reaction. Salt water is made of 2 things, water and salt. When you have Kool-Aid, You have three things in Kool-Aid. Everybody here drank Kool-Aid before? Has at least seen it? Okay. I keep telling you guys, taking pictures of this won't help. Writing it down will. And if you can't see it, move to a place where you can see it. And if we're going too fast, watch the video at home. Don't take pictures and then forget about the pictures, think you got it in your head. That won't work. So Kool-Aid, let's take a look at Kool-Aid as a really great example. Is it one word or two? I think it's hyphenated. 2 words, I think.
It's hyphenated.
It's hyphenated, yeah. Is it AID or AID? I think it's AID, yeah. All right, so Kool-Aid. With Kool-Aid, you take, and you're adding water. Water is still the solvent with Kool-Aid. You still got water. But then you add two things to this mixture. You're adding, what are the two things? Whoever's made Kool-Aid before. That's right, sugar, either some kind of, it's really just some kind of dye. It's just an edible dye. It's a food coloring. It's a dye. And then, of course, sugar. When you mix the three things together, what you get, it doesn't look like water anymore. It looks something like, this. It's some kind of colored fluid. Can you see the dye particles? When you have green Kool-Aid, can you see the little green molecules? No. You can't see any particulate. It's all, the dye's mixed completely. Do you see any sugar in it when you're drinking it? Some kids do put extra sugar, and then you get sugar at the bottom, don't you? Those are those kids. I know some of you are in this room. Those kids that really love the sugar. Yes, but hurry up. You'll get sugar at the bottom. But the sugar that's in the liquid, do you see it? No, you just see this green liquid. It's one homo. The same. Homo means the same. It's one thing that looks the same throughout. A homogeneous mixture is one thing that looks the same throughout. That's what homo means. It's same. So a homogeneous mixture is a liquid that looks the same. So this Kool-Aid is a great example. Salt water is also a really great example. As you can see, when you poured it out, all you saw was it looked like clear water. Until you taste it, then you would taste the salt. But you can't see the salt because it's dissolved completely. Dissolved means it's surrounded. So if you could look into it with a really it doesn't exist, but some really crazy microscope, what you would see is this little sodium, and we haven't talked about elements yet, but they would have the sodium. Sodium's atomic symbol is that. Has a plus, sodium plus, and you'd see a bigger atom called chlorine ion. They're both ions. And they'd be surrounded by water. Water's a molecule. And so what you'd end up with, all right. I hate it when, maybe I can zoom in. Let's see if this works. Nope. When things don't work, I really want to lose my temper, but I'm not allowed. It's not fair. You guys lose your temper all the time. Yeah, you do. Maybe not you, but I do it. We'll talk more about water, but what happens is you get water is an oxygen atom that's bound. What does the word bound mean? Attached to. Can we use the word attached? You guys cool with that? Attached to two hydrogen atoms. So when you got an oxygen atom attached to Oh, why would you do that? The hydrogens kind of surround the chlorine, and the oxygens surround the sodium. You get something that looks like this. This is what dissolve means. When we talk about dissolve, what happens is that these molecules align themselves, they dissolve each other, and the water actually separates. The water separates the sodium and the chloride. So they can't come together. You can't see the particle. It's dissolved. It's floating in the water. The water's, everything's moving all the time. I can't show you that, but the chlorine and the sodium are separated. If you looked at a salt solid, which you would see is a big clump, and I think you've looked at them, they look like little cubes of solid. That's a lot of sodium and chloride all distributed evenly, attached to one another. Water separates them, and they get dissolved. That's what dissolve means. So when we created these solutions, and you created a lot of sodium, when they have a 5% solution, what you have is you have a volume of water, the solvent, water, and then so let's say, and then you have some volume of salt that you've added to it. So you've added some amount of salt to add to the water to make it 5%. That amount is going to be more than the 0.5% solution where you added salt to it. Does that make sense? Because salt is a solute and water is a solvent. So the more solute you have in the water being the solvent, because what is concentration? Concentration is solute divided by solvent. And if that amount of solute divided by solvent is 5 parts out of 100, then you got your 5%, correct? Well, obviously, 0.5% is going to be a lot less. So the solute constant, that equals 5%. Where if you were creating a 0.5%, it would be 5 out of 1,000. That would equal 0.5%. So that's what, whereas the top number is the solute, the bottom number is the solvent. Solute divided by solvent, that is concentration. All right, so you will be quizzed on that on Friday as well. Is that in the chapter reading? Did you guys read that chapter 6 yet? You read in chapter 6, so it is there? Good to hear it. And it's chapter 6. It is in chapter 6. I'm hearing. I don't remember reading it. I have 4 books I'm reading at the same time to keep up. But
you say we're taking the quiz Monday?
Yeah, the quiz is going to be on. I'll say it one more time. The whole control group, experimental group, independent and dependent variable. You're going to have to be able to identify those. You'll be given an experiment. You'll be asked to identify which of these is the independent variable, which is the dependent variable, which is the control group, which is the experimental group. And then you're going to also be asked to calculate the concentration of a solution given a certain amount of solute, and I'll be asking you in terms of percent. You can have all kinds of units, by the way. I could put 5 grams into 10 liters, and what's the concentration? 0.5 what? Grams per liter. Right? And this is percent. Percent's the easiest thing because it's the easiest thing to imagine. But we could do all kinds of different units for concentration. But the key is, what I'm going to be looking for on Monday is, do you remember that what is a solute? What's a solvent? What's a solution? And how do and that you're dividing the solute amount by the solvent amount. If you can do that, those 4 or 5 things, you're going to ace the quiz. It's a quick quiz. All right? Should take you 5-10 minutes. So you're gonna have there will be a time limit. So make sure you're able to do it. Are we good? Yeah. All right. Yeah. And where? Up at the top, you mean? Up here? All right. This is all recorded. It's about a 16-minute video. I will upload it today right after you leave. So you'll have this at your disposal as well. I don't hear any questions. Read chapter 6. Make sure, if you want me to send you some practice questions, let me know. Wow, that was quick. Okay, I'll send you some practice questions in Jupyter. All right, you're welcome. Have a good one. Wait, is it time to leave? Hold on.
We'll leave at 7.
Well, we gotta wait 3 minutes. I gotta take attendance anyway, so that works. Okay. So the data that we're looking for is, you're going to have day 1, right? That's 24 hours. That starts today, so tomorrow, right? Tomorrow. So day 1 is tomorrow. Day 0 is today. Day 0. Day 1. Day 2. Day 3 and 3. This is Saturday, Sunday. We're gonna have water set up so that it stays moist over the week. I'm gonna have to set this. I'm gonna set this on a timer. All right, Dave. Please stop. Please stop. Thank you. Why can't we mute our phones? Because mine goes off a lot. I'm just saying, why can't we mute? Oh no. Day 5. And we're going to move on. So day 0 is today. This is obviously Friday. This is you planted them. This is when you planted them. Day 1, 2, 3, 4, 5. Come on, guys, quiet. Forget about it. Forget about it. It's not that big a deal. It really all in all, it never is a big deal. Even last year, the 9th grader big deal was not really a big deal. A bunch of girls left, and if Aiden went, life goes on. You'd all be here. I'd feel sad because I love the girl, but that's the way it goes. I told you during our safety lesson, I had 2 kids get expelled. That's fine. I didn't want it to happen, but you know, it's going to happen. So day 0, 1, 2, 3, 4, 5. So this is going to be Monday. This is Tuesday. This is Wednesday. Day 6. And then obviously day 7 is the day you plant today, which is Thursday. By the way, Thursday is also known as R. Wednesday's W, Tuesday's T, Monday's M, all right, Friday is F, all right. So that's kind of the way if you ever see these codes. In any case, what you're going to do then is you're looking for the number of seedlings in the 0% solution, 0%, 1%, I'm sorry, it would be 0%, 0.5%, 1%, 2.5%, and 5% solutions. That's it. How many seedlings? That's what you're doing. The number of seedlings. So for the 5%, for the 0%, for all of these, on the day it's planted, on day 0, you have 0 seedlings, obviously. 0 seedlings. Now, tomorrow, are there going to be seedlings? I don't know. We'll see. Honestly, I don't expect any tomorrow. Saturday, Sunday, we won't know because I'm not coming in on Saturday, Sunday. I don't know if any of you are coming in, but I'm not. I'm gonna put water in the tray, and it'll keep it watered throughout the weekend. So Saturday and Sunday, we're not going to collect data on these days, unfortunately, because I just can't come in on Saturday, Sunday. I can't handle it. I have too much to do at home. If I have to, I will, but it really is too much. So then Monday, you're going to have some number. Tuesday, you have some number. Wednesday, you'll have some number. And, of course, your hypothesis is, are there going to be any seedlings? Do you expect to see any seedlings here? Do you expect to see any seedlings here? Do you expect to see any, etc.? We already said our hypothesis for the first one. We're going to expect the expectation, and I'm going to go ahead and write it in yellow. The expectation is by Thursday, we're going to have 5 seedlings, right? Here in the distilled water, the DI water. We expect, we're not writing that in. I'm just telling you when you collect the data, but our hypothesis would be that we'd expect 5 seedlings by the end of the 7 days. Does that make sense? And because everything else was kept the same, then the only difference between the number of seedlings here, theoretically, is going to be how much salt was in that solution that you're adding to it every day. And we might have to increase the water. Now that I looked at it, some of the kids were telling me that they didn't think it was enough. We'll see about tomorrow, but we might have to increase that number to 20 milliliters. So that's expected. Our hypothesis predicts that there will be 5 seedlings here on day 7. Okay? That's what we need to do. That's what so make those charts. I'll post this along with other stuff. It is 2:39, so that gives us plenty of time to talk about solvent, solute, and solution. Let's do that.